Welcome back, geometry, to our second part of Q2, looking at some special parallelograms. This next one is called a rhombus. Notice the rhombus does look an awful lot like a parallelogram. Rhombus has all the properties of a parallelogram, as do rectangles. Rectangles and rhombuses both have all the properties of parallelograms. Plus, in a rhombus, all the sides are congruent. Okay, so that's what distinguishes rhombus from other parallelograms. So let's put the markings on from parallelograms. So parallelograms have opposite sides parallel. They have diagonals that bisect each other. They have opposite angles that are congruent. And now in this one, instead of just the opposite sides being parallel, congruent, every side is congruent. So just a single dash mark on each side, all four sides are congruent. In a rhombus, the diagonals are not, they bisect each other just like in a parallelogram, but they're not congruent to each other. Notice one is longer than the other one, but they are perpendicular. So we don't have right angle corners like in a rectangle, but we do have a right angle in the middle, right angle diagonals. Okay, the diagonals are perpendicular. Also in a rhombus, the diagonals bisect not only each other, like a parallelogram, but they also bisect the opposite angles. So not in all parallelograms, but in rhombuses specifically, and I'll erase this to make it more clear. That angle, not only are the opposite angles congruent, but they also are bisected. Okay, opposite angles are congruent and they're bisected. I'm going to put these in here so it's a little bit more clear. That it's not just one continuous loop, those are congruent angles. So this actually, something cool happens in a rhombus. We have four congruent right triangles nested in here, right? If that's perpendicular, all four of those angles are right angles, and we have right triangle with side angle side, side angle side, side angle side, side angle side. We have four congruent right triangles. Pretty cool. I'm going to put some more markings on here because those are not the same length as the hypotenuse. I mistakenly put the same number of markings on there. Okay, so let's use those properties to find some missing values. So if AB is 12, AB, this side here, 12. Now if that side is 12, then all the other sides are 12. So BC is 12, CD 12, DA also 12. AC, if AC is 10, remember the diagonals bisect each other, so each of these halves are both 5. BD is 18, the diagonals bisect, so each of those halves are 9. And now we actually have some triangles here. We have a 5, a 9, and a 12. That actually isn't right, I don't think. Because, let's see, let me check. 5 squared plus 9 squared, that's 25 plus 81, that's not 144. So that is actually not possible. Let me change one of these numbers to make this work here. I'm going to make this one I'm going to make AC. Just let me fix this here. Let me change some numbers. We're going to make it easy. So our side lengths here, instead of being 12, I'm going to make those 15. Just so the numbers work out. This one I'm going to make be 18. Because if that's 18, then these are both 9. this is 15, 15, 15, and 15. Then this would be 24. So then this would be 12, and this would be 12. Okay, that works out. Because then we have 9 squared plus 81 plus 144 is 225, which is, or this is a multiple of a 3, 4, 5 right triangle. Right? 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. Okay, that makes me feel better. Sorry about the confusion. So we're going to use these numbers instead, 15, 18, and 24. AE then would be 9, as I said. BE is 12, CE is 9, and DE is 12. There we go. And then with the angles, we start off, it's like, what do I do with the angles? They have one filled in over here. EAB is 63. EAB is 63. If that's 63, the diagonals bisect the opposite angles. So this is also 63. And if those are both 63, then these ones over here are 63. And the angles on the ends are going to be the complement of that. Remember, the angles in a right triangle, that the acute angles in a right triangle also add up to 90. So that's going to be a 27, 27, a 27, and a 27. So then any other angle that we need to find is going to be either one of those angles or a sum of one of those angles, or two of those angles. So let's check some other ones here. So angle DEA, this last one here, DEA, well, that's just one of the middle angles there. The diagonals are perpendicular, so that's 90. ECD, ECD is 63 as well. CED, CED, also 90. And actually, all the ones that have this E in the middle here don't have E, those are all 90. Right? BEC is 90. AEB is 90. Looking at these other ones here, DAE, DAE is 63. BCE, BCE, also 63. Let's put degree markings on there. EBC, EBC, 27. EDA, EDA, also 27. CDE, CDE, also 27. And ABE, ABE, also 27. Now this one didn't ask us about any of the angles on the rhombus. They only asked us about the angles formed with the diagonals. But had they asked us for ABC, we could just add the 27s together. Or had they asked us for BCD, we could just add the 63s together. So kind of nice that way. Let's look at another couple examples here. So in this one, if QR equals 10, what is RS? If QR equals 10, QR is 10. So that's one of the side lengths on this rhombus. QR is 10. What is RS? RS is also a side length, so it is also 10. Measure of angle 8. Even without any other information, if we know that this is a rhombus, 8 is one of these angles where the diagonals intersect. The diagonals bisect each other, so that is 90 degrees. Measure of angle 2 and angle 1. Let's see, angle 1 and angle 2 put together. Well, those are the acute angles in a right triangle, so they also must add up to 90. So even without knowing anything else about this rhombus, we at least know that. So then in this one, measure of angle 2 is 2x plus 7. Measure of angle 7 is 4x minus 21. Let's look where 2 and 7 are located. 2 and 7 are these two angles here. the diagonals bisect the opposite angles, so angle 2 and angle 7 are actually the same size. 2x plus 7 equals 4x minus 21. So we can then subtract 2x and add 21 to get 28 equals 2x. Then divide, oops, that's a 1. Divide by 2 to get x is 14. Okay, we will look at those other 4 together in class. We'll do that along with the rectangle problems as well. Okay, so we'll stop this video here, and I have one more shape to introduce us to, and that is actually no, I'm going to keep going. This is a this last section here. Our last shape is squares. Last shape is squares. The properties of squares that we're going to need. No, I will do another video. Never mind. We're going to stop this here, and we'll do squares in the next video. So tune in then. I'll talk to you then.